Hello everyone, I am assistant professor working in ECB college. Today I will tell about the asymptotic notation. There are three types of asymptotic notation, that is big O notation, omega notation and theta notation. Before going into these notation, we will consider some points. Any running time of any algorithm depends upon the basic four things. Three are the hardware and fourth is input. That is whether it's a single processor or multiprocessor, whether it's 32 bit or the 64 bit, or the read write speed to memory also affected. And fourth one is input. So we will consider the fourth case, that is input. That is, we consider how the program behave with any input. For this we built a hypothetical model machine which is supposed to be the 32 bit, which executes sequentially, and every arithmetic logical assignment and return statement take of time. This is the assumption we are making in our hypothetical model machine. Now consider this case. Consider first case algorithm about the this is very sum. This is a program that is it return only A and B. So this is line number 1 and it cost 2. Why cost 2? Because there is one return statement and one addition statement. The addition statement cost 1 unit of time and return statement also consume 1 unit of time. Total time consumed 2 unit of time. So it's a constant unit of time, constant time taken by the algorithm irrespective of the input. Consider second case. Case number second. Here there is a matrix and we can say array in which we have to calculate the sum of all the members of the size n. Array name is A, total A, for loop, simple program. Now line number 1, 2, 3, 4, cost total equal to 0. 1 assignment operation, so it's 1. Second, it's 2, 1 for the conditional statement, other for the incremental statement, so it will consume 2 unit of time. Third one is total operation and the total plus, that is increment operation, and last one is return statement, that is 1 number of times. This will execute only once, this will execute n plus. We will also consider the false case, and it will also check the false case, so it comes to be n plus 1. So it will execute n times and it will execute 1 time. When we add all these, look here, when we these all 1 plus 2 into n plus 1 plus 2 into n plus 1, 4n plus, it comes to be 4n plus 1. Time taken is linear to input. This is linear. This is the first case is constant and this is linear. And similarly we can say sum of matrix. If there are two matrices and we want the sum of the matrix, it comes to be the quadratic. If we see the graph, just see the graph to understand what you. Here this is sum which is constant. Here this is sum of list or sum of array which is linear. Here sum of matrix, sum of two matrices. Here it's a quadratic. This is the thing, this thing. So big O notation is represented by big O and square, and if On is big O, which is set of the form an plus b, it is of the form an square plus b. On is big O1, which is set of all the form of the constant c. So this is just notation how to represent the varied notation in the form of big O. Now the main point. This I have told you about the representation of the we first build the hypothetical and we calculate here the total cost time, and then cost time we have seen through the graph the time consumed. Here we have the rate of growth of equation is represented by the three notations. Three notations are used. First we will see big O notation. In the big O notation, to understand the big O notation, you simply see the graph here. Here, if you got n not equal to 1 and for the value some c, and there is cgn. Here, if you find some fn which will always remain low from cgn, always from certain point and not equal to 1. So this is the big tell about the worst case scenario. Big O notation tell about the worst case scenario, and is used most popularly in our study. So to give the definition, technical definition of this is there exists C and then not says that Gn is always greater than equal to Fn. That is the same graph. You see one example. Here I have taken one example, 4n square Gn. This is Fn, this is Gn, C equal to 8 and not equal to 1. So Fn equal to n square. It will give the worst case scenario of the algorithm. With this example and with this first big O notation of our lecture. Second thing, omega notation, you see this, if there lies some function fn which will always remain up from c to gn, then we will, if we find such graph, then it comes category of omega notation. Technical definition is there exist c and n naught such that cgn is less than equal to fn for all the value of n which is greater than equal to n naught. That is the thing. Here equation fn gn c equal to 4 and not equal to 0, so fn comes to be n square. This is the example. This theta notation, omega notation just gives the lower bound. It gives lower bound. Rate of by the rate of growth of gn. It means this thing. So this is about omega notation. Move forward about the third notation, that is third and the last notation, theta notation. We will first look at the see here. If some fn which will always remain between c2 gn and c1 gn and not at some point, it will, if it remain, then it comes under the category of theta notation. Let's look the technical definition. And n naught such that c1 g1 equal to fn and fn is always less than equal to c2 gn. I have taken this thing, fn gn is n square, c1 equal to 4, cn to 1, so fn equal to, this is theta notation, n naught. Rate of growth of gn to the fn. It gives the tight bound. What do you mean by tight bound? Tight bound, it will tell the lower and upper bound. So these are the three basic notation. First is omega notation. Omega notation tells about the worst case in our cases. Second is the omega notation. Third is the theta notation, backward notations, and we have seen through the graph and some examples about these notations, and also this, what are these notations also. So I think you have about the asymptotic notation, that is about the asymptotic notation, three types of notation, how to calculate the hypothetical bands. Basically I have considered only the input this thing. So these three notation omega and theta will be clear. Thank you very much.